let's see what we can do here, okay? By the way, just a bit of a hint, well, not necessarily a hint, but something that might help you. Remember, I started off with a definition of just regular symmetry, like symmetry of a general type, right? And we said symmetry is when, and then I gave you a definition. Do you still have that there? Got it? Yeah. Okay, now, I am going to give you a definition, and I want you to hear how similar it is to the previous one, okay? And then we'll unpack it. So, rotational symmetry is, and here's my sentence which I'd love you to write underneath yours, okay? Is when you can rotate a shape, right? And after rotating it, you will get the same shape, exactly the same shape in exactly the same place, right? You get exactly the same shape, and I'm very pleased that some of you have used even that phrase because that's how we're trying to understand this whole idea. Exactly the same shape in exactly the same place. Okay, now lots of shapes that you know have rotational symmetry, okay? So let's think of some examples, okay? Yeah, would you like to take this one? Okay, I'm going to draw a circle up here. I will come back to the circle in a moment though. I want to think of a simpler, I know circles are very simple, but I want to think of a simpler shape. Yeah, a square, excellent. Now, if you have not thought of that, that's okay, but I would like you all to draw a square. Okay, very important. Now you remember before I would give a shape and then I would reflect it across, right? And then we would label. We would label the points and then see what happens. Okay. So for instance, this shape here, right? It's a square. I'm going to call it square A, B, C, D. Okay. Now, just like how reflectional symmetry, right? You had a special line and you could reflect across it and that's where it was symmetrical. What did we call that special line? Started with an A. Yeah, Rashad? Axis. The axis, good. I've heard it a few times, that's okay. The axis of symmetry, right? Well, when you rotate things, the ingredients that go into rotation, it's not a straight line, right? What's the ingredient that goes into this? Yeah. Yeah, there's a point. I've actually drawn it in here, okay? So we call it the center of symmetry. Okay, bless you. Now, just like how you have ingredients that go into a reflection or rotation, right? What do I need? I need more than a point, don't I? What else do I have to talk about? If I want to have a rotation, I need... What else do I need? Yeah, I need an angle. Good, because, for instance, just have a look at this. Don't draw this, but just as an example, right? Suppose I was to rotate this 45 degrees. 45 degrees. What would happen? Okay, well, I'm guessing it'll look something like this. Is that about right? You can see A, that'd become A1, right? B would become B1, you get the idea. Now, let's have a look at this. This is not the exact same shape in the same place, is it? Right? But a square really does have rotational symmetry. So, can someone give me a suggestion for how should I rotate it instead? 45 degrees doesn't work. What could I do as an alternative? Yeah, Ash. 90 degrees, okay. So I've got my A, B, C, D here. Okay, so when I rotate it, and I'd love you to do this as well, if you've got another color, that will really help. This A, right, where's it going to go? It's going to come around to here. It's going to rotate around this point. Okay, so A will become A1 over here, right on top of B. In the same way, B is going to become B1 over here, right on top of C, and so on. Okay. So now when I connect these all up, I have a very Christmassy looking square, but the important thing is, it's the exact same shape in the exact same place.